John, thanks for making the time again today. It is so great to continue our discussions around our ER&I asset-intensive industries and what we're doing to help digitally transform them. So thank you for joining.
And I always enjoy spending time with you. I think I take as much away from these conversations as I like to share.
Glad that we can make this happen. So when we last met, we had talked offline afterwards about it would be great to bring some real world examples of some of the challenges that we see our clients facing. And in particular, to dive deeper into some of the areas of the Golden Triangle. So for those that are joining us for the first time, one area that we talk about is the product area of the Golden Triangle. So products, assets, and customers. So let's double click on product if we can. It's one of my favorite areas to discuss. And maybe talk a little bit about some of the challenges that I know that we mutually face with our clients around the areas of product and product data. So one of the ones that I like to talk about that I see everywhere is amalgamated SKUs, essentially that long transactional SKU that might exist from legacy ERP systems that brings together both product data, which is unique to a product's fit, form, and function, as well as, of course, transactional data, whether that's manufacturing transactional data or customer transactional data. In many of our clients, we see that amalgamated as one unique product ID, which makes it really hard for our client then to help to configure new products, create new products, and understand the attributes that are driving the value around that product, and also to create unique pricing strategies. So certainly that's one of the main ones that we see. What do you see out in the industry?
Well, from my perspective, as you know, we have roots in discrete manufacturing, but if you bring that over into energy and resources, we have products, in this case, very physical products on seabed floors. They could be small modular reactors behind the meter at chemical plants, as well as fluid products like polyethylene, polyolefins, and so forth. For us, the challenge has been, how do we bring that digital twin into the field? We're all products of the experiences we've had along our career. One of the experiences I've seen is when you look at the product that's being produced, and you look at, and it depends on which product. Well, let's clarify in our conversation here. When we're saying product, are we saying the product that clients can have that they produce to produce other products, or are we talking about that product? Or both?
Both. In some ways, right? Because ultimately we're helping our clients create their initial product, right? And that might be a B2B type product, right? But ultimately it trickles down to the end consumer. I mean, one of the great unique positions that our industry holds is something like 80 to 90% of products today are produced with the chemicals that our clients initially produce. And so it provides us at a unique step in the value chain to create that product, the products, and impact those products down value stream. So to your point, as you were mentioning, creating the digital twins, right, or creating the products that help assist in tracking the monetization of that product throughout the value chain is super important.
Yeah. So challenges I've seen. So let's look at the full life cycle. So we may have somebody who has products on the seabed floor. So we're doing production on the seabed floor, and then we carry that forward, and we have to look at, if you will, precise production, and the challenge of bringing that, onshore. And then we've got refining, and we've got the ability to now create these B2B products, and as you said, then become the B2C products that hit the store shelves. So there's really a challenge of scale, right? Looking, and again, you're wanting to focus on or double click on that product portion of the Golden Triangle. So if I think about that, I think about the challenges we see with products. So I'll shift gears a little bit, and I'll tell you about something that's happened very recently, and then we can carry it back maybe to other products. So one of the challenges we have is our species is electrifying the entire planet, right? Electrification is everywhere. Even within, let's say, the chemical world, we're looking to electrify.
Crackers.
Exactly, we're looking for process intensification, electrification. We're driving out every form of waste, be it carbon waste or physical waste, all of this is being ripped out. So as we electrify and the demand for example, small modular reactors, you might have seen the headline in 2021, I'm from Texas. So in 2021, we had a month, in the month of February, we had a freeze that shut the entire state down for 30 days. And you had businesses, the secondary and tertiary effects from that were felt throughout the United States and the world. Because when you turn off the entire Gulf Coast of production there, all those processes, all of manufacturing that's looking, for example, materials for car seats. So you had various car makers that had to wind down their operations until supply could be turned back on. So the reaction to that was in January of 23, we had a very large chemical company announced that they were going to bring and put small modular reactors behind the meter in Seadrift, Texas. And so that's just one headline of innumerable headlines now, where we're starting to see the transformation of the entire process industry and what that looks like. Well, the challenge there is we're not on the factory floor with just specialty equipment. It has to be engineered and configured for each unique environment as we go forward. And so that product supply chain has been challenging how do I bring the digital twin from the factory floor and into the field and maintain a continuous data management, design data management, construction data management, commissioning, walk down, and then on into operations. And now that I'm in operations, now how do I look at the full life cycle with my assets there? And again, we'll double click on asset data, at another time. But then on the product side, all of this contributes eventually to the ability to produce at scale with the right quality these products that our customers seek. So while we focus on one part of your golden triangle, it's interesting. We always find the connective tissue between the others. So as we start to transform how we manage design data, design of experiments, research and development, that whole world around the product, bringing it to scale, because that transformation isn't linear. I mean, the need for physics-informed digital twins around especially chemical products like specialty lubricants that you might find, or any number of other products, salad dressings, I mean, you name it. The beauty is when you start to scale it up, we now have the computational power and the ability to understand the multivariate environment that you're encountering as you go to scale. It's never just linear, because when you think about the surface area of containers versus the volume that they contain, as you start to raise it up, and how that's not a pure linear, it's exponential in its relationship, the demands on our ability to analyze and to extrapolate and to build at scale can now be recognized in a digital environment. So as you ask about the product, I get real excited about the computational backbone that we're now able to bring to bear for that. So it's these trends, these challenges would have been intimidating years ago. In fact, you and I were talking about this, that it feels like it's taking 10 to 20 years to get to a point where now everything has to happen overnight. So it's like this accordion effect. It was like we wanted for so long to be able to see these capabilities around product quality, product availability, volume of product, customization of products, all the demands that go with that. And it's been this accordion effect that now, and I think we talked about this in another episode where you were discussing how the consumer experiences we have made their way into the industrial side. And it's really incredible to see how the expectations around product availability, product variability, the customization of those products on demand, the traceability around the supply chain, that accordion effect now of we expect this all like yesterday in industry. It's tremendous.
It's true. It's very exciting. And we are at a precipice from an industrial perspective. We're just about to have that exponential growth. You can almost feel it out there, that everything is finally coming together from a transformation point of view, from a quantum computing point of view, also from an industry maturity point of view, to really have those key ingredients for the formula for success for our clients. Let's think specifically for this industry on the fact that unlike our discrete counterpart industries, this industry is very process-based, right? And so we often have to talk about also not just creating digital twins of our assets, but also how do we get those molecules from the lab, from the science of creation of those molecules at the atomic level through the scale-up process, right? And out from engineering into full, through pilot and through full production. And so oftentimes it is a long, elaborated, risk-averse process, right? I mean, high throughput experimentation, when it came out maybe 10, 15 years ago now, helped to accelerate it. But what we're also now seeing as well, which is really exciting, is our clients thinking about the data around that molecule in a different way than they used to historically. So previously, when we would create that data around the molecule, it would stay within our LIMS systems or within our labs for quite some time. And it would be happenstance or luck that we would come across a really great formula that we then realized we could sell billions of dollars worth at the product level. But now what we're looking to do is structure the data that's coming out of science. When you talk about scientists, I've known a few over my life, including family members. They're great pioneers. They think very abstractly. They want to come up with new applications for molecules. They want to come up with brand new compounds that we've never seen before. Their thought pattern is a very unstructured thought pattern. That's how they create those products. That's how they create those unique ideas. We need that to remain in that way, but to manufacture that product at scale, to your point, and really monetize that product, we have to shift that unstructured data that's in the lab in various different beakers and things like that that are going on in your lab, or various different LIMS systems, and streamline and structure that data in a way that our assets, our manufacturing assets, our digital twins can consume it. And so one of those things that has been really exciting about the precipice that we sit at for our industry right now is starting to truly see the bridge occur from a data perspective, from science to engineering, from that molecule to monetization that we were talking about earlier. And so oftentimes that comes with disamalgamating the different data, looking at, we find attribute-based data models where we say this compound has X, Y, and Z attributes that you might be able to either monetize against or market against or put claims against, so our formulas-based clients can then try and remonetize that molecule for a different claim set or a different client set. So it's also really exciting for us because they're starting to think about how to monetize their products in a different way than they used to historically, let's say 15 or 20 years ago.
I'm excited about some of the recent investments we've made as Siemens. The ability to, if you will, the same mindset around design data that we have for discrete objects, and now to be able to bring that into the laboratory, and as you said, still foster the creativity, the kind of almost unstructured creativity, but be able to capture that as a scientist is moving through. But we capture that data, and then when they want to run prototypes, right? How do we run that at scale? We have the ability to do that now. You're talking about creating novel products, if you will, out of the laboratory. The beauty is we can now simulate at a molecular level the interactions. That's what's so tremendous about some of our recent investments. We now can carry things through a molecular level to a, for lack of a better term, a macro level or a physical world level, where I can look at the interactions of those molecules, in the beaker, as you like to say. But it's now when I want to bring it to scale, I still can get that level of fidelity. So Siemens has made some incredible investments that allow us a level of fidelity at a molecular level that you and I would have never seen before just a handful of years ago. So we talk about the creativity that needs to still be fostered. Well, now we have that creativity, but with speed. We can move through so many different permutations and combinations that actually, I think, help drive even greater creativity we never would have thought possible.
Absolutely. We find new applications, right? And new ways, new process engineering models that we can then optimize how we're creating those molecules in a way that we only dreamed of 20 years ago, or we knew was possible, but we didn't quite get there digitally. And I love how you brought up how now from a science perspective, we are trying to be digitally native in how we develop and incubate those new molecules. Rather than go back and document later, we try and trace that creation right from the very beginning. Both from a PLM perspective, if we're talking about a PLM-based system, but also with other products, for example, that you guys have on your accelerator platform, and also looking at it from a laboratory perspective, and even from an artificial intelligence or machine learning platforms, there's others that are trying to help accelerate that creation as well.
Well, and the interesting thing is, as you're moving through this kind of creative surge that a scientist will have, you've got to understand your requirements too around the end products, performance and so forth. So when you look at investments we've made around molecular level simulation, you couple that together with requirements management. You lay on top of requirements management artificial intelligence to make sure you don't miss any of these voluminous requirements. You couple that together with a journey of computational fluid dynamics and finite element analysis and other physics-informed capabilities that allow you to now scale up in a nonlinear fashion, account for turbulence, account for all these multivariate environments. It is truly impressive how, as we think about what you discuss, how do we move at scale from the laboratory forward, but also making sure that we gather all of that creativity. We don't lose it all, right? It's almost like what I picture is, the mad scientist notebook and what it must look like. But if we can provide a digital environment where as these thoughts are coming forward and as we can capture them, because sometimes there's inspirations that'll be long lost, with pencil and paper that we now capture going forward. And the price of prototyping, the price of the design of experiments is, it's still there from a digital perspective, but it's practically non-existent. It's incredible what we have now armed our scientists with.
Absolutely. Deloitte has done some great work on working on a digital lab assistant to that point. You were saying earlier, we use chatbots and AI, right, to ask questions. And sometimes with our scientists, they can't write their great ideas down fast enough. So having a digital lab assistant that can not only better capture some of those outputs, but then also ask follow-on questions or ask probing opportunities at adjacent applications or adjacent raw materials, then it just drives and accelerates new opportunity. By the fact that we're accelerating this new product development, to your point, going from requirement all the way through scale up and then through execution for bill of material productions to our ERP systems and then getting those products out to customers. What a great way to save our clients money. One of our clients' favorite topics when they say, all right, we're going to be investing millions of dollars to digitally transform ourselves. What are we getting for our great investment? And I know we've spoken before about how some of our clients self-pay for their implementations based off the tens or hundreds of millions of dollars that they've saved from not only scale-up time alone, but then also raw material synergies and other supply chain synergies that they're able to gain just from better understanding their manufacturing process and potentially being able to swap out components within their bill of materials. So certainly I know one of your favorite topics to discuss, right, is molecules to margin and molecule to monetization, as I refer to it. So what are your favorite areas of savings for some of our clients?
Well, we've had a great history of saving significant engineering design hours. We've had clients with distributed offices, disaggregated all over the world, right? And so by their very nature, they're already siloed. And so by putting in a digital backbone, a true digital backbone, as we've done in the discrete space, where we've seen enormous return on investment just when your engineers are spending, you'll see studies, they'll say, well, they spend 40% of their day looking for information. It's like, no, actually, they probably spend about 80% of their day looking for that. They probably just don't want to tell anybody. So if you can get people out of the business of looking for information and instead acting on that information, acting on that data, what you're actually paying them to do, it's an impressive return on investment in what some of our customers have seen significant percentages in what's been saved in design data management, being able to actually execute the work of design and engineering as opposed to looking for data.
Absolutely. And when we talk about engineers, those aren't cheap resources,
No.
right? And so being able to redeploy that thought capital, oftentimes, some of our clients will say, oh, well, we don't want to cut resources or anything. And we say, no, absolutely not. We're not looking necessarily to cut resources. It's also about redeploying that thought leadership and that brain capacity to creating new products, to solving more client problems, to solving, some of their customers' challenges, for example, when they're out in the marketplace. So it's such a great opportunity not only to save them hard dollars for these implementations or in labor savings, to your point, but also to help them redeploy that workforce so that they can grow without having to hire more resources.
You mentioned the digital twin earlier. And one of the things I want to make sure that we're clear about and what we share with our audience is the digital twin isn't just the molecule anymore. It is, for our conversation here, that product. But what's interesting is we're now dealing with clients who say, well, I might have a monoclonal antibody that I'm developing, and I've got the syringe that I'm going to use to deploy it, and I've got the manufacturing floor to develop these products, the syringes, and get these out the door. But then I've got the entire factory. And so the digital twin for the product, what's interesting is they now want the digital twin of the entire factory. That is what they consider to be the product twin. And then they'll want to cookie cutter it country by country. And then, of course, you have to configure to the conditions of that country, be it, subsurface when you're building it is different, the ambient conditions are different, the temperatures, pressures, humidity, and so forth, the various skill levels you might have in that country. So what's interesting is the scale of what is considered product or would influence the product and what they expect on day one as a complete solution around that product digital twin is no longer just the laboratory. It's that and everything that comes after that all at once.
And it goes to this point of the fact that that golden triangle, the connective tissue, that digital thread around it is almost kinetic. It's alive when you start to change any piece of that golden triangle. So to your point, anything on those asset conditions change, or we need to replicate that asset in a market that's closer to our customer, for example, to be able to get product there faster. It inevitably alters the homeostasis of the other two pieces of that golden triangle. And so it's not just about digitizing the product. We have to digitize the full golden triangle and the full ecosystem, the full enterprise becomes alive so that it can also be responsive and resilient to disruptions. I mean, when we talk about savings, so we've already touched on, you can get product margin savings by getting to market faster. We've talked about raw material savings. You've touched upon labor savings, which is a great one. Another one that we typically also see with our clients is that they are seeing significant savings from not having downtime. So when we talk about downtime in our industry, it's always a dirty word. You started this conversation by talking about the downtime that you guys experienced in Texas several years ago when the entire infrastructure froze over, right? And it caused trickle-down effect throughout the supply chain that we all had to come to a standstill or slow our capacity. When we slow our capacity, we're not making as much money, inevitably. And so being able to minimize the disruptions to that golden triangle or the disruptions to our overall supply chain is where we're also seeing our clients save millions of dollars by ensuring that their enterprise is digitized and kinetic enough that we can predict how it will respond and how it will become more resilient in times of disruption, whether that's a completely unexpected one like a COVID or weather disruptions as our climate continues to change,
right,
as an example, or even self-made disruptions, based on supply chain shifts or regulatory shifts, et cetera. It's all about being able to react in real time.
Well, interestingly enough, you talk about reacting in real time. It pops into mind. We had a client with a highly viscous material that they would have to pump through long haul lines.
Mm-hmm.
And one of the challenges they had was they had to balance drag reducing agents against pumping power. And so they had to deal with, I won't say innumerable, let's say just a whole lot of utilities along these long haul lines that were interstate, while at the same time they also had to account for the potential for DRA or drag reducing agent injection. The challenge is, how do you simulate an entire product system like that, right? Well, maybe 10 years ago, that would have been a challenge.
Can you imagine doing that all on paper and pencil? We did back in the day.
Oh, I know.
Or
we
even
tried
computers,
to,
and we
right?
tried to.
Exactly.
But it's amazing when you think about what we tried to achieve before we really got to computational dynamics on supercomputers.
The digital twin.
And quantum computing. It's
amazing,
amazing,
my gosh,
right?
Absolutely. No, the digital twin at scale is truly remarkable. And you're able to actually now balance out. We saved a ton of cost because, I mean, you think about the fact that they're trying to draw from utilities that are using, let's say, renewable energy like wind and solar. At peak times during the day, the cost per kilowatt hour is just unbelievable, right? But then you've got drag reducing agents, which are very expensive, by mass. And so how do you balance all that? How do you go back to the CFO and say, because of this digital investment, we can now in real time, or at least 24 hours out from when we have predictive pricing on what the utilities will now charge us, I can now actually optimize the balance of what it will take to move product, to B2B in this case. And that's just a direct line to your balance sheet, right, on value.
I completely concur with that point. And I know we are trying to get to that nirvana state, right, where we can predict in real time and be able to make those calculations on the fly, right, for those drag reducing agents and how fast you're getting them through the pipeline. And let's be real here for a second. We're not fully there yet where we can actually do it with the rate that those fluids are going through the pipelines, et cetera. It's hard to do in truly complete real time. But we are close, and we are closer than we've ever been before in getting there as an industry. And so the more that we can invest in this, both within our industries, but then also with our downstream industries, the faster we'll get there.
We actually had a client where when there was some changes in the recipe or the formula, it ended up actually changing the pH enough that downstream, we actually had to tie. You mentioned this before when you're tying asset data and product data and customer data. What ended up happening was because there was some stainless steel lined spools and tanks downstream, this actually was going to cause a problem. And so the ability to be able to make changes in the laboratory, but understand its long-term effects before, can you imagine having done all that work, the plant's been assembled and you've got this great product, and now what you don't realize is that somewhere along the line, a minor ingredient was changed that affected pH, and that pH now has a corrosion or an embrittlement issue that it causes. And now you have to go, can you imagine the cost that you have?
And imagine how today, right, when we think about the best practices for how we avoid those real implications of late decisions or late realization in product creation, and think about how today our leading practices is we bring collaborative environments where we didn't have, let's say, as much transportation and logistics or supply chain, or EH&S teams were separate from the core product data platforms that we have them in today. By bringing them all into one collaborative environment, including our suppliers and our customers, those individuals are able to point that out much earlier in the process based on those requirements or based on those attributes around that product than they were previously. So I think exciting part of this story also is that by creating collaborative environments around the kinetic energy that's going on around that golden triangle, we're able to your point, solve those problems faster and identify those pain points a little bit sooner in the process.
I love your use of vocabulary, static versus kinetic, right? I do really think we have a kinetic digital twin. And I'm going to copy your homework on that. I really think that's brilliant because the digital twin is not static. I mean, every day, if you send a young engineer out and she just is taking, let's say, a tablet, and all she's doing is a visual observation, you've just changed the environment, right? You've just changed the data stream on that asset. So I really do think it's a very dynamic, but I like that word, kinetic digital twin is the expectation now. And with products, it's a pebble in the pond scenario.
It is.
The slightest changes in the recipe. What are the long-term effects? And so you've double-clicked on the product side of your triangle, but you can't double-click on it and not address asset and customer. So to me, I find myself slipping as we're talking into the asset side of the business because that's my experience, because I understand hydrogen embrittlement, right? Steel corrosion cracking, all the corrosivity issues that you're going to get from the most minor changes in the product that flows.
So John, you know what you're signing yourself up for. We're just going to have to get together again to have some more of these discussions around those other areas. But before we go, one other thing I want to talk about, because I think this conversation also brings it to a head, is not only are our enterprises becoming more kinetic, right, or becoming more digitally enabled throughout the entire enterprise, is that we are seeing our full enterprises change over or transform. So enterprise level transformation is something that Siemens and Deloitte do really well, right? So we're not just in the trenches solving for product data. We understand how product data is a pebble in the pond throughout the rest of your enterprise. So when you are doing a new PLM system, you also have to take into account, how does that product hierarchy, how does that BOM structure have a ripple effect across our ERP systems, our e-commerce systems, our quality systems, all of the downstream consuming systems that inevitably your product data flows into. And I know that Siemens takes a similar approach in how you guys are developing and looking at your product suites so that your products continually interconnect and talk to each other.
Right.
So talk to
And we go so far
that.
as to call it a digital thread, right? So we really do see from the laboratory to the field as this intertwined enterprise. And so when we take a big enterprise view, but the beauty is we also understand that, to swallow that elephant, for lack of a better metaphor, it is building blocks to get there. So working with Deloitte, the beauty is us working together, we can build that roadmap of building blocks to finally recognize what we often call the industrial metaverse. So the industrial metaverse, this high fidelity, physics informed ability to experiment in the virtual long before you get to the real. And to be able to keep that cost of prototyping down, that cost of configuration or engineer to order down, because you're actually going through all of these experiments, this design space exploration, if you will. That ability to do that and then do it in an industrial metaverse. Now, when you and I first started talking years ago, we would say, what is your capital asset lifecycle management, right? What is that full spectrum of, I've got suppliers sending me heat exchangers, fractionation towers, spools of pipe. Now I'm going to assemble all this together, this system of systems. What is that capital asset life cycle? What you and I have now been discussing is you've got product life cycle management with a product. You've got capital asset life cycle management with your assets. When you bring in the customer data, right? And now we're able to affect the product and the capital asset life cycle management because we have such a strong connection to customer requirements. It becomes a tremendous metaverse solution for us.
Absolutely.
And for you, for us to build together for our clients.
Together. And our customers have a life cycle too, right? Ultimately as well. And when they're looking at, moving away from a product, we need to retire that product.
That's right.
Right? And that's how we'll save inefficiencies and SKU proliferation, and it flows back through.
Deloitte has industry expertise, change management leadership. We bring in design data management, and that entire product life cycles with the ability to manage complexity as a competitive advantage. It's a perfect marriage.
I couldn't agree with you more, John. And as we've mentioned, it's going to be great to double click on the remaining areas of our golden triangle together. So I can't wait to hopefully sit together sometime soon and discuss those remaining areas. So I look forward to seeing you again soon.
It's always my pleasure.
Can't wait for it.